This video is about functions of three variables. Now, when we had functions of two variables in the past, every location on the xy plane had an associated z value with it. It had a height that we could assign to a surface. In the case of three variables, we could think of every point in three-dimensional space having a value associated with it. Now, there's no fourth physical dimension to extend those values into, so it's a little bit harder to conceptualize. But let's see if we can figure it out by determining what a function's value is at different points in three-dimensional space. Consider this cube of variable density. Let's say that its density is a function of x, y, and z, and it has the formula 1 plus xyz, grams per cubic centimeter. Now, obviously, depending on where we are in the cube, the density value will change according to that formula. And it'll represent the material making up the cube. This cube's sides have a length of 4 centimeters, and one of the corners is at the origin. What would be the density of the material at the following points? So at the origin, in order for us to find the density, we want to plug it into the formula. So here we'll have d equals f of 0, 0, 0, and it'll be 1 plus 0 times 0 times 0. It's 1 gram per cubic centimeter at that point. If we want to find the density at this point 1, 2, 3, we'll plug into the formula. That's 7 grams per cubic centimeter. And finally, for the point 4, 4, 4, that's going to give us 65 grams per cubic centimeter. All right, so where are all these points in the cube itself? Well, here's one at the origin, and remember it was 1 gram per cubic centimeter there. That was the density. We have the point 1, 2, 3. Let's see, 1 in the x, 2 in the y, and then we'll go up to about 3. And that was a little hard to see exactly where it's located. But it was 7 grams per cubic centimeter there, so it's more dense. Then finally, 4, 4, 4 would be the very edge of the cube. And here it has a density of 65 grams per cubic centimeter. So instead of having a uniform density, there's a variable density.